All right, so today we are going to be talking about how to actually write a lab report, like a formal lab report that you'd see in college and as a science professional. So there are a few different sections that go into a lab report. So first, obviously, you have the title. Our title here is combustion because we're talking about combustion reactions. Next is the abstract. This is kind of like a summary of what goes on in the experiment. It's just really brief. A lot of times when you're doing research, this is what I did in college, looking for articles to support a thesis, you would read through a bunch of abstracts, and it's a quick way, instead of reading through a whole 20-page article, you read through 2 paragraphs of the abstract, and you can see whether that you want to read the rest of that paper, request access to that paper, whatever it is. It's just a quick summary, like what happened in the experiments, what did they find, like what is this about? And that's a good way to tell what it's about and if it's actually going to be useful to you. So we're actually going to save the abstract for last because it's summarizing our whole report. We're going to save it for last because we don't even know what we're doing yet. So then we're going to look at the introduction. This is where you talk about your materials, like what's going on. And here we're talking about combustion reactions. So in a combustion reaction, a fuel combines with oxygen. Remember, that was that hydrocarbon that we were talking about, fuel or hydrocarbon, and it's combining with that oxygen. The most common fuels are hydrocarbons, compounds made up of carbon and hydrogen, and alcohols. So these are also carbon and hydrogen, but they contain the OH group. Combustion of hydrocarbons and alcohols always produce carbon dioxide and water. We knew that. We talked about combustion reactions. So the hypothesis that the temperature of the surroundings will blank because energy is being, okay. So think of what you know about combustion reactions. We talked about fire, burning, those key words that we talk about when we're talking about combustion reactions. So if something is getting lit on fire, if something is burning, what will the temperature of the surroundings do? Do you feel hot or cold? You feel hot. Like when you have a fire going, it feels hot. So the temperature of the surroundings will increase because the energy is being absorbed or released? Released in this case. So now we're talking about materials and methods. This is a really important section when we are writing a lab report because it allows other people to recreate your experiment, and that is super important in science, that an experiment is repeatable, or that a hypothesis is testable and the experiment is repeatable. So the experiments were performed at Waukesha High School. Yep. In the first experiment, the teacher added approximately 2 grams of lycopodium powder to a long tube and connected to a funnel. The teacher blew the lycopodium powder into a Bunsen burner flame. So right now I want you to go and watch the lycopodium video. So pause this video, go back into WebEx or PP9 and go watch that lycopodium video. All right, did you watch that? Awesome, that is a really cool video. A giant fireball is produced, and I know you can't feel it through your computer screen, but it actually gets really, really warm. So, write down some of your observations from that video. What did you see happening? All right. I know you can't see this you can't feel this through your screen, but the temperature change observed is you could feel heat. Okay, now we're going to talk about our second experiment. There's another video for you to watch. The teacher connected a gas jet to a plastic funnel. So our methane gas jets that we use for our Bunsen burners, instead of attaching it to a Bunsen burner, we attached it to a funnel. We poured some soap solution into that funnel to produce methane bubbles. So just like the bubbles you would blow when you were a little kid, now we are doing that, but instead of just like air, like whatever's coming from our lungs going into those, we're actually blowing methane into them. So the methane bubbles were scooped into a wet hand and lit on fire using a flaming wooden split. Go watch that video. The one about the methane bubbles. Go watch it. Okay. Those are so cool. Like, if you were in person, which I wish you all could be, our students who are here in person are actually going to have a chance to do that themselves and actually light their hands on fire with those methane bubbles. So, super cool. You feel a little bit of heat, but that water that they dipped their hand in first actually protects their hand from like actually burning or like any damage happening to the skin. So, temperature change observed. It feels hot. When you light those bubbles on fire, they feel warm. They feel very hot. And write down your observations. What do you see happening? Is there fire? Is there a color change? What do you see happening? All right, so now I want you to summarize your results. In both experiments, what is the common factor? What is happening? Is there a temperature change? Do that here. All right, and now so pause me if you need more time. You have control. Okay, so now we're going to talk about, does the data support your hypothesis? So here we need to restate our hypothesis and explain. This is the important part. You must explain as well. So our hypothesis make sure you guys are still on screen. Nope. There we go. Our hypothesis stated that the temperature of the surroundings will increase because energy is being released. Okay, there's your hypothesis. Now explain how you know that. During the experiment, I felt the heat. During the experiment, there was a temperature change. Something along those lines to explain how you actually know that the surroundings increased in temperature. All right. Okay, now we've done the discussion. That's like the last part of our lab report, summarizing everything, telling the people the last results, like how you knew that happened. Now we're gonna go back and talk about our abstract. Okay, so there's 4 parts of an abstract. There's the purpose, which is written for you. These 2 experiments were performed to investigate the temperature change during a combustion reaction. Cool, that was our purpose. Methods. First, lycopodium powder was blown into a Bunsen burner. Second, methane bubbles were lit on fire using a Bunsen burner flame. That's what we did. That's our methods. Results. We discovered that the temperature of the combustion reactions increase or decrease? Increase. This suggests that combustion reactions are, so there's 2 big fancy words, endothermic or exothermic. Exothermic. Because energy is absorbed or released released. And you have finished a formal lab report. Congratulations. So, we're going to do the back side, but make sure this gets turned into Google Classroom. All right. Now we're going to talk about the back, and we're going to talk about combustion equations practice. So we're going to practice writing combustion equations. Okay. So, if you remember, the format equation was on page, I believe that was 100. We have CXHX, so basically our hydrocarbon, plus O2 is going to give me CO2 plus H2O. So our hydrocarbon plus oxygen is going to give me carbon dioxide, carbon dioxide plus water. Okay, so in a combustion reaction, there is one thing that changes. That is our hydrocarbon. This is what's going to be what changes. Every single dang time, you are going to see this. Smudges it. Okay. Every single time. O2 is going to give me CO2 and H2O. O2 getting me CO2 and H2O. O2. Okay? Every single time. Okay, so now we're going to talk about these and how to balance them because they are kind of tricky to balance. So we're going to start with them written out where we're just practicing balancing. Then we are going to move along to having them partially written out for us, and then you're going to write them up yourself. But I believe in you. You can definitely write these up. Writing these without balancing them, just like identifying the type of reaction, without balancing them is a B. So if you can write them, that's a B. And you can walk away with your B and be happy with that. If you want that extra challenge, want to push yourself, you can balance them, and balancing them correctly would get you to that A. Okay, now let's talk about how we actually balance them. So I'm going to get out a pencil for this because I tend to make mistakes balancing or have to go back and change things, so I don't like to scribble it out. So I just use a pencil. Okay, so my number one tip for you is start with carbon. Always start with carbon. We got one here, one here. Then move on to your hydrogens. I have 4. I have 2. How many carbons do I want? 4 divide, that gives me 2. So 2 times 2 is 4. I have 1 oxygen now. 2 times 1 is 2, so I have 2 here. Here's the tricky part. You have 2 sets of oxygen in your products. So you have 2 O's here, and you have to add these together. So you have 2 plus 2 is going to give me 4. So I have 2 oxygens over here currently, and I want 4. Division, 4 divided by 2 gives me 2. So let's check. I've got 1 carbon, 4 hydrogen, 4 hydrogen, 4 oxygen, 2 plus 2 is 4 oxygen. I'm all set. We also give you these tables over here if you want to use them. If you don't want them, go for it. I got 1 and 1 carbon, 4 hydrogen, 4 hydrogen, 4 O's, 4 O's. If you want to use them, they're there for you. This is our reactant side. This is our product side. Whatever method you like. All right, ethanol. A little more complicated. Bigger molecule. So here you have an O here, an O here you have to add, and you also have H's you have to add. So a little bit more going on. All right, let's make sure that our equation is written out correctly. We have our ethanol, our hydrocarbon. O2 is giving me CO2 and H2O. That's great. That's correct. It's looking how it's supposed to look. All right. Let's just start by counting up everything that we already have. We have 2. I'm going to add these together right away. I have 6. I'm going to add these together right away. No, I'm not. I apologize. I'm not going to do that. And I have 3. I have 2. 1, 2, 2, 1. All right. We start with our carbons. 2 over here, 1 over here is 2. I have 6 hydrogens. 3. 3 times 2 is 6. 3 times 1 is 3. 2 times 1 is 2. 2 times 2 is 4. So I have 2 and 2. I have 6 and 6. I have 3 and 7. So I have 6. I have 2 and 1 plus 2 gives me 3. So I have 7 over here. I've got 1 here. So I can take that 7 and subtract 1 because I already have 1. And I'm left with 6. So now I want 6 here is 3. And now I'm balanced. Let's double check. 2 carbons, 6 hydrogens, 1, 6. 1 plus 6 equals 7 oxygens. I can actually do 5 plus 1 here. Okay. 2 carbons, 4 plus 3. 4 plus 3 gives me 7. This is still the wrong spot. I'm sorry, guys. Let's start with hydrogens. We got 6 hydrogens, and 4 plus 3 is 7 oxygens. Okay, I'm gonna let you guys do this one, but we're gonna talk about number 4, which is our heptane. Okay, so our hydrocarbon comes first, C7H16, and I'm going to recommend that you draw a little spot for the coefficient, plus blank amount of O2s. Remember, this is where we get our constant formula, right here, is going to give me blank amount of CO2 and blank amount of H2O. The only thing changing is this hydrocarbon. Okay, I'm gonna let you do the rest. Make sure you answer number 7, what is easy about writing combustion equations, what's difficult, and then check your answers on BB9. And we'll see you in class.